Today we're going to solve quadratics by factoring, which could be a little rough because this is where a lot of you struggled freshman year. So what we're going to do is we're going to basically review most of the factoring you did freshman year in a day. If we look at this quadratic here and it's graphed, and we were to solve this by graphing, we'd say, okay, well, I'm at 3 and 5 for my x-intercepts, and that should be the solutions to this. Now, it just so happens that if we set it equal to 0 and actually did factor, and for those of you who remember how to factor from freshman year, we find what multiplies to 15 adds to -8. We'll review that in a minute, and we know that's actually 3 and 5, but both of them are negative. And then we set that equal to 0 by our zero product principle. We can say x minus 3 equals 0 and x minus 5 equals 0. So x equals 3 and 5. What do you know? By factoring, we get the x-intercepts, which are the solutions or the roots of that graph. And that's as easy as it gets. For the most part, this is the simplest type of factoring. We'll go in and just review that real quick. So when I have a quadratic in the form 1x squared plus bx plus c, the c term is the product of the factored constant terms, or the c terms. The b term is the sum of the factored constant terms. So let's do a couple real quick. This guy, we want to know what multiplies to -24, adds to 10. Well, that's x, and in this case we have 12 and 2, which I think is going to do it. So I have a -12 and a +2. So x minus 12 equals 0, x plus 2 equals 0. I get x equals 12 and x equals -2, which would also be the intercepts of that graph. Now, we want to solve this quadratic. However, it's in a different form. We don't have a side set equal to 0, so I want to do that and also rearrange it so that I so you'll see in this form we have a quadratic once again, but it's not set equal to 0. We always want to, if a quadratic is given to us and we're asked to solve it, set that quadratic equal to 0 and rearrange the terms so it's in x squared plus bx plus c form. So here we go. We want to know what multiplies to +36 adds to -20. Like so. I know that's going to be 2 and 18. So you got to brush up on your multiplication tables. X minus 2 is 0. X minus 18 is 0. So x equals 2 and 18. So here's a word problem kind of associated with this. Wants to build an art studio that has 3 times the area of the old studio by increasing the length and width by the same amount. What should the new dimension of the studio be? Well, we know the initial area is equal to 120. So the new area has to be 3 times that, which is 360. All right, and 360 is going to be the area of this rectangular region that is length by width. So my new length is x plus 12. My old length, or my new width, is x plus 10. That's going to be equal to my 360. If I want to solve this, I have to get it in quadratic form, so I'm going to have to FOIL. That's x squared plus 10x plus 12x plus 120 is equal to 360. As in our last example, we said we have to set aside equal to 0. So that's x squared plus 22x minus 240 is equal to 0. We want to know what multiplies to 240 and adds to 22. And again, you'll have a calculator with you, so you'll have to do some trial and error, but it ends up being 30 and 8, positive 30, negative 8. And so in this case, we set x plus 30 equal to 0 and x minus 8 equal to 0. So I get x equals negative 30, x equals 8. We have two answers, but only one makes any sense. We can't have a negative length to add to, so we get rid of that, and we add 8 to both sides, and they want the dimensions of the new studio. Well, if I add 8 to both sides, I have a 20 by 18 studio. So next we're going to move to solving an ax squared plus bx plus c model. And if you notice, here's a couple terms that are in ax plus bx plus c form in their factored form. Notice if I distribute all these out, I'll get these guys on the right. But you also have to notice that this pattern that existed for 1x squared plus bx plus c isn't going to be the same. What multiplies to negative 6 here doesn't always add to negative 1. In this case it does, but in this case it certainly doesn't, because what multiplies to 2 and adds to 9 is sure not 2 and 1. In this case, granted, these things did multiply to negative 6, but added to 1. That's strictly coincidental, so you'll see it's not always the same. So we've got to find a method for factoring these new terms in this form. What I do is something called a 5-step method. If you've learned another way from another teacher that you like better, go ahead and do it. I'm going to show you this way. So the key to this is, first of all, make sure all GCFs, and we'll talk about that later too, have been factored. Alright, so you have to make sure there's no common factors to begin with. So we're going to multiply our a term by our c term in our first step. I get x squared minus 15x minus 16. Second step, we're going to take and factor the remaining term here. So notice I have a 1x squared minus 15 minus 16. That's just what multiplies to negative 16, adds to negative 15. So it's x and x, 16 and 1, negative and positive. That's step 2. Step 3, we're going to divide our a term into our factored constants. So that means take and divide 1 by the original a term, which was 4, and 16, and divide that by the original a term, which is 4. Our fourth step is to take and reduce any fractions. So 1/4 doesn't reduce, but 16 over 4 does, like so. And then we want to take and bring any denominators to the leading variable that remain. So here I have a denominator remaining. I want to bring that to the variable. So that's 4x plus 1 and x minus 4. Taking a look at the FOIL, there's 4x squared minus 16x plus x minus 4, or 4x squared minus 15x minus 4, which is what we were trying to factor in the first place. So that's just a method for factoring this type of quantity. If you want to use it, go right ahead. I'm going to use it throughout this lesson. So I want to take and solve this term. Notice terms are a little bit bigger, but I'm going to still multiply the 4 times the 35, so I get x squared plus 24x plus 140 is equal to 0. I need to find out what multiplies to 140 and add to 24. That's pretty easy. That's x plus 10, x plus 14, Then I'm going to have to divide by my original term. Notice both of these reduce, so I have x plus 5/4, or I'm sorry, 5/2, and x plus 7/2. Since I have two remaining fractions, I bring my denominator to the front. Like so. Just do a real quick check. There's 4, 14 and 10 make 24, and there's my 35, so I set 2x plus 5 equal to 0, 2x plus 7 equal to 0, and I get x equals negative 5/2 and x equals negative 7/2. In this case, we notice not set equal to 0, do so. And go through the same process, multiply. Find out what multiplies to 80, adds to 11. That's x plus 16, x minus 5. Divide by 2 to both cases. First term reduces. Second term, I bring my remaining denominator forward, so I have x plus 8 equals 0, 2x minus 5 equals 0, so x equals negative 8, and x equals 5/2. Let's do another word problem. Want to purchase a table for the lobby. Table comes in different dimensions. For every table, the length is 1 meter greater than twice the width. So we can call this the length. And let's call the width. And the length I want to express in terms of the width. So it's 1 more than twice the width. And they budgeted the tabletop area is supposed to be 3. So now we'll write the equation for the area, which is length times width is equal to the area. Distribute. Set the side equal to 0 because it's a quadratic. Go 5-step method. We multiply, get plus 3 minus 2. Divide by the 2. Reduce fractions. Bring any remaining fraction forward, so that's 2w plus 3. W minus 1. Set them both equal to 0. Get 1 and negative 3/2. The negative 3/2 makes no sense. So we have a width of 1 and a length of 3. So now we move into GCF factoring, greatest common factoring, or factoring by grouping. Greatest common factor is find one number or term that goes into both terms in the expression. So in this case, I have an 8 going into 16 and 24, and an x going into x to the 4th and x. So I pull out an 8x, and I have to say 8x times what gives me these two quantities. That's a 2x cubed and a 3. When I multiply back by distributing, I should get that term back. Now, you'll notice in this case we have 4 terms. Typically when you see 4 terms, you're factoring by grouping, and grouping is exactly what it sounds like. You group in pairs typically, sometimes not, but in this case, yes. We see we have a GCF of 2x squared, leaving me with a 3x and a minus 2. In this case, I have a 5 in common, and I'm left with a 3x minus 2. Now you'll notice that we also, in this next step, have a 3x minus 2 in common. So I'm going to factor that out. And 3x minus 2 times what is 2x squared times 3x minus 2? That's 2x squared. And 3x minus 2 times what is 5 times 3x minus 2? That's plus 5. And so that's factoring by grouping. So you'll notice in this example we've got a GCF running across of, it looks like there's a 2 that goes into every term and there's an x squared in every term. I also am not particularly a fan of having a leading negative coefficient, so I'm going to factor out a negative 2x squared. That leaves me with a positive 12x squared, a negative 8xy, and a negative 15y squared. You'll also notice here I have two variables. I'll show you how we deal with that now. We're going to have to do our 5-step. So I take x squared minus 8xy minus 180 y squared. What multiplies to 180 adds to 8. Not too hard. That's x and x, and notice how I deal with these y's. There's a y here and a y here, making y squared. To get 180 and get 8, I'm going to go 18 and 10. 18 goes negative, 10 is positive, and then I'm going to divide by the 12. Reduce both, so that's negative 2x, x plus 5, 6y, and x minus 3 halves y. Bring that denominator term forward. And then your question might be, well, how do I get this xy term? Well, this is my 12x squared. This is negative 18xy and positive 10xy, which is negative 8xy. And then here's our 15. So that's completely factored. So here we have another ball throwing problem, if you will, and we have the time t. The height is given by h of t, and we want to know how high is the object after 3 seconds. Pretty easy, we just plug that in. So that's negative 16 times 3 squared plus 160 times 3 plus 1200. We can just plug that into the calculator, and I get 1536 feet. Then we want to know how long does it take to hit the ground. Well, that's when the height is equal to 0. So I have negative 16 t squared plus 160 t plus 1200 equals 0. This is looking like a factoring problem, and 16 does go into 1200, so I'm going to pull out a negative 16. That's multiplied by t squared minus 10t, and then 1200 divided by 16 is going to be 75, so that's minus 75 equals 0. Now what I can do here is I can divide by negative 16 right away to both sides. So I have t squared minus 10t minus 75. 16 goes into 0 times. And what multiplies to 75 and gets me 10? That's going to be t minus 15, t plus 5. So I get t equals 15 and negative 5. Makes no sense to have negative 5 seconds. So after 15 seconds, it hits the ground. That's all we've got. And make sure you do your Connect Dead. We'll see you tomorrow.